Hello everyone and welcome back to another video, and this is another one that was actually requested but that I also wanted to make before it was requested, so now I have two reasons to make it. This is a graphics card stabbing guide, and just like the last video it also kind of applies to everything else that has VRMs, but since I mostly do graphics cards and I don't really have anything else to show here on camera, I'm just gonna say graphics cards. But yeah, if you have the very basic skill of pattern recognition, you're gonna know what to do on a motherboard as well. So, what does the stabbing guide mean? Well, we're gonna take a multimeter, we're gonna stab the graphics card with these probes, and we're gonna measure resistances and voltages. Because that's also a thing that a lot of people have problems with. Like, people understand the basic of, okay, we're gonna measure the voltage, but like, how exactly are we doing that? Well, it's actually pretty simple, but sadly this doesn't, like, at least not in Germany. No one tells you how this works in school. You gotta figure it out somehow, even though it's quite basic. So, let's first start with resistances, because that's the first thing pretty much you gotta do when you get a graphics card that you don't know of if it works. By the way, this is also going to go into some common failures, like how to detect shorts, but the first part of the video is going to be just how to stab in general. So let's get the 670 out of the way. That's gonna be important later, and let's look at this 580 direct CO2. So, I've just set the multimeter to resistance mode. As you can see here, it's set to 200 ohms because my multimeter does not auto range. You have to pick a resistance range that you expect the resistance you measure to be in. Some fancier multimeters can auto range. There you just select resistance and it automatically finds the range. On mine you have to set it, so I just set the lowest because 200 ohms is generally still above the thing we're going to measure here. So, your multimeter has a black probe and mostly a red probe. I think some have like orange or like green probes. But basically, actually it's only really important for voltage measurement, but I just really like to use the black probe for ground because you also do that for voltage measurement. For resistance it's not really that important, but I still use the black probe for ground. So, if you measure resistance and also if you measure voltage, you always connect one of your probes. Again, I always do the black one. You connect that probe to ground. So, the ground plane of the graphics card. Ground is found pretty much everywhere. Screw holes are ground. The metal around the display connectors is ground. The I/O shield is ground. The 12-volt connectors have also ground connections, which when the clip thing shows into your direction, looking down on the board like this, the exposed ones are ground. Some graphics cards have the connectors flipped around, then they have the nose on this side, then the inner ones are ground. Yeah, and every capacitor also has a ground side. You can see it pretty easily on SMD aluminum polymers or tantalums, like this tantalum right here. It has a plus on the white side, which tells us this is the positive side, which means the negative side is ground. The other one also has it marked like this orange strip here is positive. The other caps also have a strip that show the positive side. The CAN type capacitors have also a marking that shows the negative side actually. So where the black part is, that's ground. So you can just go to the back of the board when it's through hole and connect that. That's also ground. Like, ground can be found pretty much everywhere. I prefer to just use the display connectors because these are designed to have a lot of power going through them, because just because it's connected to ground doesn't mean it's a really good connection. You can use it. Resistances are usually not affected if you use a not well connected ground like a screw hole, but for voltages it can skew the result a bit. So I just like to use the ground from the power connectors. And let's say we want to measure the resistance of the core. So let's go to a capacitor. we see from the marking, it's not really that great to see on camera, but we see the marking is on top. But the solder on these capacitors is a bit corroded, so yeah, but there it is. There's the core resistance. The solder is a bit corroded, so it's not super accurate, but 600, 500, 700 milliohms, whatever it shows, that's what you would expect for a Fermi core, like a big Fermi core, though the smaller ones are also not that different. Okay, that's a bit high. Connection might not be that great. We can also use a different capacitor, like these really small ones, these multi-layer ceramics. These also have a ground side. Sadly, there it's not marked, so you just gotta have to find the right side. One side is gonna be 0 ohms. Okay, so we just got V-core. If you would measure the wrong side, you would just get 0 or 0.1, which is the minimum that my multimeter will show. And then the other side should be higher resistance. So here we have again our 500 milliohms for the core. Another thing that you can do is just use the inductors. On this card you can only access them from the back, which is why I prefer to use capacitors. But in other cards like the 670, which I'm going to show shortly, you have SMD inductors, and there you can just go to the inductor. Doesn't matter what leg we're measuring resistances. Even for voltages it would be okay, because the multimeter is nowhere near as accurate enough. It's just gonna measure, it's just gonna even out the voltage reading. So it's gonna appear like you measure the output of the inductor even though you're at input. So here we have again 500 milliohms from the inductor. As ground point, I'm just using the through-hole point of the power connector again. And this is a tie-in to the last video where I said on this card it's kind of difficult to see where V-core ends and VMEM starts. By the way, if those terms don't mean anything to you, I would advise you to watch the video before this, where I go into what's on a PCB. But yeah, I said you can figure out with resistance measurements pretty easily what is what. So we measure this inductor, that's core. We measure this one, that's also core. We measure this one, that's not core. That's a lot higher, that's 56 ohms. So that's how we know that this is memory, because memory is usually, 50 ohms is kind of on the low side, if I remember correctly. It can be in the hundreds of ohms sometimes, but like the core is a lot lower. The core is basically 0. Like if you put this into continuity mode, it's gonna complain about a short circuit, even though there is no short circuit. The core has just a very low resistance. And sometimes it might even complain about memory. Mine does. So my multimeter also thinks that this 50 ohm resistance from the memory is a short circuit, which it's not. That's how it's supposed to be. So yeah, don't use continuity mode. Always use resistance mode, because your multimeter is gonna complain about short circuits where there are no short circuits. So yeah, that's as far as this card goes. Let's look at the 670, because that one does not have through-hole inductors, so you can see there's no through-hole things on the back for the inductors. This has SMD inductors, which means we can measure from the front. Now sadly the power connectors have no exposed connections right here, so I'm just gonna use the display connector, and I'm gonna touch the inductor, and we have 7 ohms. That's actually pretty high. Like, it's a small 28 nanometer core. Like the GK104 is pretty small compared to like big Kepler on the 780 Ti. So this should have a higher resistance. Like the smaller a core is, the higher the resistance is. But 7 ohms is actually a lot. I was expecting something like 2 ohms, but yeah, maybe the connection's just bad. No, this one reads 7 ohms too. Okay, so our core has 7 ohms, or maybe that's just the ground not being that great. Let's test the screw hole. It's slightly lower. But yeah, this really small core, like compared to this, you can see from how far the thermal paste spreads. This is a pretty small core, and then big Kepler is, I think, even bigger than this. So yeah. And the memory array on this also has SMD inductors, and I'm gonna demonstrate that you can also measure from the 12 volt side. Now you can see this resistance is a bit higher, again because we have less memory chips, and less memory chips in parallel mean that the resistance is higher. So yeah, 71 ohms, that's pretty much to be expected of a memory VRM. So that's pretty much the basics of measuring resistance. And actually, if you measure voltage, the only thing you change is you set your multimeter to voltage mode. So like you see, I set it to 2 volts now. If I would measure something like the 12 volt power plant, I would set it to 20. But for the output of VRMs, I just set it to 2 volts. And you do exactly the same thing. I can't really demonstrate it right now because I have nothing to power the card. But again, you would connect one probe to ground, the other to whatever you want to measure, so like the output from your VRM. And if the card was running, you would see a voltage now. There's one more thing to keep in mind for voltage measurement, and that is that voltage drops the farther away the point you measure is from the VRM. So let's say, I've also talked about this before. I don't know if, no, I don't think I talked about this in the last video. But yeah, voltage drops. A good example for that is the memory VRM. So the memory VRM on this card is over here. Well, it's there on most cards. And so these two memory chips are really, really close to it. And the memory VRM is gonna put out something like 1.6 volts, usually. So these two memory chips will get pretty much 1.6 volts. But then this memory chip and this memory chip that are very, very far away from the VRM do not get 1.6 volts because over that large distance the voltage drops a bit. So these might only get 1.57 volts. And that might be limiting for your overclocking. Same goes for the core. The voltage that you measure at the VRM output is gonna be higher than that you measure behind the core. So what do I mean with behind the core? You see, memory chips and the GPU also have capacitors behind them. And if you want the most accurate voltage measurement that doesn't involve an oscilloscope, you measure from there. You measure as close to the thing you're trying to power as possible. So again, you would connect one probe to ground, and then you would find, say, a multi-layer ceramic capacitor like this one, or like this one, or behind the core, also like these bigger ones. It's not that great on this card, for an example, because there's a prod laser capacitor there. Let's say one of the multi-layer ceramics in the middle right here. You would find the positive side of one of these, which again only works by trying out, because multi-layer ceramics do not have a marked positive and negative side because they're not polarized. You can put them on whatever. So instead of stabbing the output of the inductor, you would stab the positive side of a capacitor that's to the nearest to the thing you're trying to power, because then you're gonna get a lower voltage measurement, and that's also the voltage that actually goes into the part. So when you see people log voltages, you're gonna also on motherboards, you're gonna see people say something like 1.3 volts set, 1.25 volts actual, because the VRM might be outputting 1.3 volts, but over the distance, even the short distance, that's just a few centimeters, the voltage still drops because the power plane and everything that's between the VRM output and the core does have a little bit of resistance, and resistance drops voltage. So you measure as close to the thing you're trying to power for the voltage, and that will give you a close estimate as to what voltage is actually going into the part. It's still gonna be higher, especially for CPUs. It's gonna be higher than what actually goes into it, because like for a CPU, you have a CPU socket, you have a CPU substrate, and then it actually goes into the die. It's similar for a GPU, but you do not have a socket here, you just have a BGA, then a substrate, and then it goes into the die, which is also still quite a distance, but for GPUs it's not as bad as for CPUs because you do not have a socket here. So yeah, if you want the best, most accurate voltage measurements, measure behind the core and at the memory chips, not at the VRAM output. Like you can measure at the VRAM output if you just want to compare voltages. But if you want to know the closest, like if you want to have the most accurate measurement as to what voltage is actually going into the part you're powering, measure as close to it as possible. So that's pretty much it. Like it's not that difficult, it's just something that barely anyone talks about. So yeah, again, for voltage and resistance measurement, you take one probe, connect it to ground, and then the other probe to whatever you're trying to measure. So now let's get into some common failures on GPUs. Because I also wanted to go into like if you pick up a graphics card from eBay and it says like untested, or like you know something's wrong with it but it still kinda works, or just you straight up buy a broken one and hope to fix it, or let's say one of your own graphics cards just drops dead one day. So when you break out the multimeter is when the failure mode is like it shuts off the entire PC when you try to start it, or when the PC starts, like the fans on the graphics card spin, but like the graphics card is not putting out an image, or the motherboard postcode even says GPU not detected. That's kind of the two situations where you would break up the multimeter. Because if the graphics card powers up and shows artifacts on screen, there's not gonna be anything wrong with it electrically, that's gonna be silicon or BGA damage, which, okay, it's kind of electrical damage, but like not fixable by soldering. You need a hot air gun, hot air the core and hope that it works, which is not a guarantee because hot airing anything to repair it is not really that great of an idea. Even though I've done it and it has been successful 3 out of 4 times. So yeah. The kind of worse variation of this is when the graphics card just doesn't start. Like you press the power button and the PC shuts off immediately. That indicates that you have a pretty big dramatic short somewhere on the graphics card. That could be a 12 volts to ground, it could be a 12 volts to V-core, it could be a V-core to ground short. Like pretty much any short that connects 2 big power planes. So how would you detect that? Well, you would take your resistance measurement again, and let's say we try to find a 12 volts to ground short. It kind of already tells you where to connect. So you connect one probe to ground again, and then you connect the other probe to the 12 volts power plane. So like on the PC, you have one 12 volts power plane on the PCI Express slot. And on this graphics card, it's pretty convenient because you have those fuses right here. So you don't have to find which pins are 12 volts, you just connect to the fuse. And we see we have no reading because there's no connection there. Or like the resistance is so high. Like if you go to the maximum resistance setting, we might get a measurement. Yeah, it's like, it's dropping. So it's 0.2, whatever. Like it's, like what's the measurement here? Like it's in the kilo ohm range. Like that's okay. So that's not a short. Now, guess I'm actually gonna have to use a different ground because I need to go there. So let's check the other 12 volt connector. Also kilo ohm range. And this one, also kilo ohm range. These 2 fuses are in parallel, so you only have to measure one. Yeah, that's what you wanna see, because that resistance is so high that, no, that's no short, because a short would just be 0 ohms. Like that would be, like if it's doing that. Because if I connect now here, no beeping. If I do this, it might beep at the beginning, but like if you keep no beeping, also no beeping. Like if it keeps beeping like this, then you have a problem. A short beep at the beginning, that's just a multimeter not getting the right measurement right away. So, yeah. But again, be wary of using continuity mode, because it is very trigger happy for false alarms, because the resistances of quad memory are so low. So that would be a 12 volts to ground short. The next thing, that's actually the... like a 12 volts to ground is also very destructive, but the most destructive is a 12 volts to V-core. So what you would do there is just you to take any V-core measurement. Like, is that the V-core side of the cap? I think this was... Yep, that's the V-core side. Now you would check any 12 volts power plane. This connected? Nope. This shorted? Nope. This shorted? Nope. So there's no connection between any of the 12 volts power connectors and the V-core output. If you would find one of the connectors that does have a short to V-core, that indicates a dead high side MOSFET. And you can kind of narrow it down, because you can check what connector this is. Like, if you know that one of the connectors is shorted, you take every phase that's connected to that connector, and then you can narrow it down where the dead MOSFET is. Okay, and then the last big scary short would just be a V-core to ground, which we've already measured that, because that's how you measure recoil resistance. Like, that's where a lot of false alarms get triggered. Like, this is really, really low. This is 500 milliohms. This might be tempting to look like a short, but it's not. This card is working, it's perfectly healthy. And actually the big problem is, on NVIDIA 10, 20 and 30 series, the core resistance is actually so low that it actually looks like a short circuit. Like, you need a specialized milliohm multimeter to measure the core resistances on these. And even then, it might look like a short. So, yeah, that's kind of a really, really painful thing to figure out. But like, on this card, you can see that this is not shorted, because if it was shorted, it would say 0.1 or just 0. This says 0.5, so this is okay. So that would be kind of the first situation, where the card is just no longer powering on, like where the PC shuts off immediately because your power supply hits overcurrent protection or short circuit protection. And yeah, most of the time, if you have a card like that, you can already see like a crater or burnt component on the PCB, but that's not always the case. I've had dead high side MOSFETs that look perfectly normal. But yeah, that would be the first situation, where the card just won't let the PC boot because there's a big short circuit on it. The second situation is PC powers on, but there's no image. That usually indicates that at least part of the VRMs on the card do not power on anymore. That can have a variety of reasons. I had a 970 that had a dead DRMOS that was shorting 12 volts to V-core, but there was a fuse and the fuse burned out. And without the fuse, there was no power getting to the V-core VRM anymore. So the card just didn't have any V-core power. And without power for the core, the PC might turn on, but if the card is not powered, it's just as if there was no card in the system anywhere. So yeah, it will just like look there's no graphics card installed, even though the fans might be powered, but like your PC won't know that the fans are running. Your PC is waiting for a message from the graphics card initializing, and that won't happen if you don't have power for everything on the card. And the way you can diagnose that is just, well, you turn the card on. I would still do a sanity check and measure resistances first, because if there's a short, especially one from 12 volts to core, you do not want to turn the card on, because a short from 12 volts to V-core, that means there's 12 volts shorted through the VRM into your core, and 2 volts is enough to kill the core dead, like forever dead, and you're shooting 12 volts into there. It is like if you turn the card on, like technically it would be enough to do it once. I can say from experience that at least the power supply I have in my test bench has a very, very fast reaction time. And I had it happen several times that I had a broken high-side MOSFET with the shot from 12 volts to VCore, and the cards always ended up living. But not everyone has a fast power supply. So yeah, do check resistances before turning anything on that you know is kind of sketchy. But yeah, you would turn the card on, and you would do a voltage measurement. Like on this card, well, normally this has a back plate, but I mean, most of the time the core VRM will not run if you have such a problem. And if the core is not getting power, you can just remove the heatsink and put the card in like that, because if the core is not getting power, it's not getting hot, which is also a really easy way to find out if the VCore VRM is running. Without the multimeter, you just take the cooler off, you hold your thumb to the core after you clean the thermal paste off, of course. You hold your thumb to the card, turn it on, and if the core gets ouch hot, the VCore VRM is running. If it's not getting hot, well, you have at least a not running VCore VRM. Sometimes on some more complex cards, if the VCore VRM is not running, it's also sending a signal to power down the memory and then the smaller minor rails. I had another 970 that did this. It had a broken VCore, but it also had no memory and PACs. But once I desoldered the memory controller, memory and PACs came back up. So yeah, you would do a voltage measurement. So on this card, I would just remove the heatsink, assuming the core is not running, and yeah, I would just measure like memory voltage, core voltage, wherever the PACs rail is on this thing. And yeah, it's like you're probably gonna find one rail. It's not always a major rail, it can be a minor rail like the PACs one. But yeah, you will very likely find one rail, at least one rail on the card that is not powering up. And if that's not powering up, well, you're gonna have to look into data sheets and check like, is there anything visual like that would indicate that something's dead? Or like, yeah, if it's like a minor rail, I would just, where did I put this? Like minor rails that do not pull a lot of power, I would just use one of these and set it to whatever voltage the rail needs and power it with that. If it's like a memory or a core VRM, well, you can't really do that, because those pull a lot of current, and those small PCB, like those small buck converters, do not have enough amperage. I think these are rated like 3 amps, which the VCore VRM is most of the times that's capable of hundreds of amps. So yeah, not replacing that. But yeah, like when you go into finding the dead rail and trying to repair it, that's really where there's no universal approach. You're gonna have to look at it at a case-by-case basis, look into the components of that rail, and then like look at data sheets and figure out what's happening, like probe some outputs of the controller, maybe if it's like throwing an error signal or something. And like, I mean, if it's a minor rail, I would just replace it. If it's like memory or VCore, I would try to repair it. Or if you're feeling really lucky, I would try something like this in ePower, where you just remove the VRM and then power it with the VRM of another card. Or like, you can buy prepared ePower modules, but yeah, this is made from another GTX 580. Sadly, this doesn't really work. Like, the memory on this works, but the core has some issues, which is why I'm not using it yet. I talked a bit about this on the stream, about the GTX 580, how this is not working. But yeah, and the video has reached 30 minutes. So I think I'll be cutting off some minutes at the beginning. But yeah, so those are like common failure modes that I see. And yeah, the video is really long enough by now. Don't really have anything to add. I don't really want to add anything. This video is way too long already. So yeah, hope you enjoyed watching this graphics card stabbing guide. And until we see each other next time, goodbye.